Okay. Hello, everyone, and thank you for joining us for week 12 of the Oxygen Concentrator Talk brought to you by the Oxygen Alliance. My name is Mwavi Lungu, and I'm currently in Lilongwe, Malawi, and I'm very pleased to be hosting the call today. So for those of you that may not be aware, the Concentrator Talk is a virtual meeting that the Oxygen Alliance hosts every Thursday from 2 to 3 p.m. Central African time to discuss different aspects of oxygen concentrator assessment, use, and maintenance. So we also encourage you to send us questions in advance, and you can do that through our email, info@oxygenalliance.org, and we'll do our best to respond to all those questions. Joining me on the call today are my colleagues, Amaprit Rai and Timothy Mtonga, along with our technicians who will be answering your questions today from OpenO2 and Sunrai. So for the technicians, we have Kowinda Singh joining us from Chandigarh, India. We have Paulina Mohosho joining us from Johannesburg, South Africa. We have Teto Sinjani, Georgie Kwanga, Sharon Gozo, and Francis Sambani joining in from Lilongwe, Malawi. So just a reminder to everyone that we encourage you to keep your microphones muted and your videos turned off unless you are asking a question. So as we normally do, we will have a topic of interest during the session. So please, when that time comes, make sure you are attentive and hopefully ask a lot of questions as much as you can so that we are all on the same page. So I will read out the questions, and we will also paste the questions in the chat in case you missed them. And as we usually do, we also have polls at the end of some of the questions. So when they pop up, please make sure you attend to them. All right. So jumping on to our questions now. So our first question says, I have a grandmother who has been prescribed oxygen therapy and she will be receiving therapy from home. Since the oxygen concentrator will be switched on for most of the day, I wanted to know if the oxygen concentrator does decrease over time. Do we need to be switching off the concentrator periodically, or can we run it for 24 hours straight? So I will ask Sharon Ngozo to take this one up.
Thank you, Maui. So an oxygen concentrator is prescribed as a temporary measure when hospitalized or to aid recovery at home for patients with low oxygen, depending on the patient's health. And the use of oxygen therapy at home can help raise oxygen levels. So it is compulsory to have a doctor's approval to use the device and should be used only as advised. A doctor's guidance is needed on how much oxygen has to be given to the patient, as oxygen toxicity can have adverse effects. So this means to say that a patient will be on an oxygen concentrator depending on the amount of oxygen needed and also depending on how well the patient responds to the therapy. So you should know that an oxygen concentrator will build up purity upon powering it from 21% to 80 and 90% in the first 20 minutes. So tests carried on most oxygen concentrators show that the oxygen concentration remains visually constant for periods up to 16 hours. Concentrators at 2 liters per minute showed that oxygen concentration did not vary by more than 2%. So an oxygen concentrator's concentration will vary around the same range and the variation is unworrying. So as long as power supply for the oxygen unit is available, an oxygen concentrator will supply oxygen for 24 hours and it will last 5 years or more. As long as there is need for the equipment, you can run it for 24 hours, making sure the equipment is in good condition throughout the runtime. So you need to keep replacing the water in the humidification bottle daily. You also need to clean and replace the filters at the recommended intervals. Thank you.
Thank you very much, Sharon, for that explanation. So if we have any questions from the audience, please raise your hands and then we'll help each other. Also, if we have any further comments from the other technicians, you're also free to add on to what Sharon has just explained to us. Right, it seems we do not have any questions there. So moving on to our next question now. So the next question says, I was servicing a compressor for G5 as part of routine maintenance service. After assembling the compressor, air was being released through the intake filter instead of the outlet port. What could be the cause of this? So I will ask Paulina to take this one up.
Thank you, Moabi, for the question. Okay, the most likely cause for your problem is that you misplaced the head gasket for the compressor during assembly. So before you do your compressor repair, use a marker to mark one side of the head gasket and the bottom piece as shown on the picture on screen. It is also possible that you might have placed the valve plate incorrectly. So the valve plate is composed of one-way valves, and these are the valves that let airflow only in one direction. They are placed in such a way that if you position the valve plate incorrectly, you will have the exhaust sucking in air and the intake releasing air. So the same mark that you would have done when you started repairing the compressor, that will be the mark that will help you in placing back the valve plate right correctly after servicing the compressor. So the whole practice of marking the head gasket, the head gasket and the compressor when you do your repair, that practice will help you in assembling the compressor. So just in case that you maybe forget what happened, just in case you forget where the parts were positioned, that marking will help you and you will be able to follow the mark. So you can also refer to the video on YouTube on how to service an air compressor, and the details will be posted that you can just follow the link and you will find videos on how to repair the compressor. Thank you.
Thank you very much, Paulina, for that explanation. I hope it was clear. So if we have any further comments from the other technicians, please, you're welcome to add on to the explanation that you just gave us. And if we also have questions from the audience, you're also free to ask. So we have a poll at the end of this question. So Amapreet, if you would please launch that one up.
Yes, Maui. The poll question is, have you ever faced reverse flow after doing a compressor rebuild? And Maui, do you just want to remind everyone where to access that poll?
Yes. So if you are joining us using a mobile phone, then if you go to the bottom right of your screen and hit on the menus option, you see a window that will pop up, and one of the options on the window that opens is the activities menu. So if you click on the activities menu, you should be able to see pause as one of the options listed. If you are joining from a computer, then you also go to the bottom right of your screen, and the last icon to the far right is the activities button. So if you click on that, you should also be able to see the pause menu from there.
Thanks, Maui. It seems like most people have not faced this problem. We only had a couple votes for yes.
All right. Thank you very much, Amapreet. So moving on with our questions. The next question says, I was working on the Vilbis 525 concentrator that was producing low oxygen purity. In the process of troubleshooting, I found that the compressor outlet airline was damaged. I replaced the pipe with another one, but to my surprise, the purity was high for a short period and then started dropping. What could be the cause of such a problem and how can I resolve it? I'll ask Teto to take this one up.
All right. Thank you, Maui. So It is good to rectify such leakage problems as it stops the air from escaping and allows you to get the required performance of your oxygen concentrator. So it is important to take note that when feeding back the airline, you need to make sure that the pipe is not touching the compressor. This is because when the compressor is running, it gradually gets hot, and this can cause the airline to get hot and affecting the air inside. This hot air itself makes the oxygen purity drop. So if you can see the image on the left, you can see that the pipe is not sitting very well. It's more like leaning on the compressor itself. So sometimes you might even as well get a puncture on the pipe and the air might be escaping. So the proper way to avoid such problems is to make sure that the outlet airliner is well attached to the fan guard. This will help in preventing heating issues. And you can literally observe on the picture to the right that the hose itself, it's running just on top of the fan guard. And it's advisable that you put a cable tie, other people call it a tie up. So you need to clip it to the fan guard so that whenever you move the oxygen concentrator, it doesn't move along, it stays stable and it's not leaning on the compressor itself. Yeah, thank you, Maui.
Thank you very much, Mteto, for that explanation. I hope that was clear. But in case we have any questions from the audience, you are welcome to raise your hand and ask the question. If you also have any further comments from the other technician, you're also welcome to add on to what Mteto just presented to us. All right. So, yes, Mteto.
Yeah, maybe just to add on, just to add on, in terms of the heating issue, sometimes it's very recommended, like for these Devil Bees 525, when you're testing them, make sure that you have the covers on, because the covers themselves, they help in the air circulation inside the concentrator. So if you leave one cover aside, you might have the concentrator inside heating up and affecting the oxygen purity as well. Yeah.
Great. All right, so we also have another poll at the end of this question. So Amapri, if you would please launch that one up.
Yes, this poll is, do you always perform a leak test when repairing a concentrator? And we'll give it a few seconds for everyone to answer. And it looks like everyone has said yes, which is fantastic because, of course, best practices do include performing a leak test really anytime you open a concentrator. So that's really great to see.
Great. Thank you very much, Amapri. So our next question, we started discussing this question in our previous session. So it came from Abena. She had an issue with one of the concentrators she's been working on, but I see she's not on the participants list. Should we skip it for now, Amapri? Maybe she has just delayed in joining.
Yeah, why don't we come back to it towards the end? And if she hasn't been able to join, then she can always watch the recording after.
Yeah, all right, great. All right, so moving on to our next question now. So the next question says, I am servicing an oxygen concentrator whose compressor is not working and is rated 110 volts. I have a spare compressor of the same model, but it is rated 220 volts, and the voltage that we get from our socket outlets is 220 volts. If I replace the 110 volts compressor with the 220 volts compressor, what will happen? Will the unit work? So I'll ask Kuwinda to take this one up.
Thanks, Bobby. So every oxygen concentrator model has a voltage or power rating, which is likely to be different from that of the other concentrator models. For example, the concentrator which is rated 110 volt will obviously have a 110 volt compressor and the transformer with the primary voltage rating of 110 volt. So if you have 220 volt at the socket outlets, to use this concentrator, you will have to use a step down transformer where you can plug in the concentrator. So to answer your question, if you replace a 110 volt compressor with a 220 volt compressor and supply the unit with 220 volt AC, the compressor will run when you switch the unit on. But the step down transformer will eventually get damaged. So the transformer inside the machine that will be get damaged, and as a result, the components on the board will also get damaged. So thus the unit will not work. So always check the voltage rating of the oxygen concentrator, which is usually stated on a sticker at the back of the concentrator. Before connecting it to the mains, it can also be found in the manual. So ensure that only the recommended voltage rating is supplied to the concentrator. So in the recent times of COVID, we have seen a lot of machines which were donated or brought from other countries in India. So because in India we are having 220 volt AC. So the 110 voltage, when we plug it on, it automatically circuit breaker will trip off firstly. In case it runs, then it will damage the machine. So please take care about the supplies which is to be supplied to the concentrator. Thank you.
Thank you very much, Kowinda, for that explanation. I hope that was clear. But if we have any questions from the audience, please raise your hands, and then Kowinda will answer all questions that you have. If we also have any further comments from the other technicians, you're also welcome to add on to the explanation that he just gave us. All right, seems we don't have questions. And we have another poll at the end of this question again. So it looks like it's polls day today. So Amapreet, if you would please launch that one up.
Yes, Maui. Our poll is, what voltage supply do you get from your power grid? This is obviously a very important issue, as Gulwinder just explained, with the influx of concentrators being donated from different countries for COVID response. So it seems like everyone is voting for the 220 volt to 240 volt range, which is what I would have expected. The biggest country, of course, that uses 110 volt is the US.
Great. Thank you very much, Amapreet. So just a reminder to all of us, especially those who are joining us for the first time. I see we have a couple of new attendees. We encourage you to share with us your email addresses so that we can add you to our mailing list, so that we should be sending you reminders of the Concentrator Talk Mar and updates of the Oxygen Alliance. So please just paste your email addresses in the chat and just let us know where you are joining from, and we'll add you to our mailing list. All right, so moving on with our questions. Our next question says, I am a technician at a district hospital. I received a Respironics oxygen concentrator from the male ward that was producing low oxygen levels as indicated by the low oxygen light. During the maintenance process, I unscrewed the covers and noticed that it contains 3 sieve beds. How does this concentrator work? So I'll ask George to take this one up.
Thank you, Maui. Respironics oxygen concentrators consist of filters, a compressor, sieve beds, solenoid valves, an electronic control board, flow meters, and a cooling fan. It's like another oxygen concentrator such as the AirSafe developers. So the Respironics oxygen concentrator use the same principle of pressure swing adsorption process to concentrate oxygen from the room air. So both the pneumatic and the electronic operation of the responding oxygen concentrator model are the same with other models. Therefore, if you are familiar with other oxygen concentrator models, you will not have problems with servicing the responding oxygen concentrator. So different concentrator models have different setup of internal parts and also the design of other components, such as the product tank. One of the canisters on the sieve canister module that you saw inside the electronics is not a sieve bed, as you are sure. It is a product tank. So that means this is a concentrator model, has also closed beds, just like in other oxygen concentrators. If you happen to have problems with servicing this concentrator, I recommend that you refer to the service manual of the electronics concentrator. And if you have problems, please contact us through our email address, which is info@oxyalliance.org. Thank you so much.
Thank you very much, George, for that explanation. So if we have any questions from the audience, you are welcome to raise your hand and we'll help each other sort it out. And if we have any further comments from the other technicians, you're also free to add on to what George has just explained. So we also have another poll at the end of this question. So Amapri, if you would please launch that one up.
Yes. Okay, the question is this model of concentrator common in your area? And we'll give everyone a few seconds to answer that question. So far the votes are very split, which I find surprising. Respironics is one of the big American manufacturers. Not that they manufacture in America any longer, but certainly the company does. But it seems like we actually have more no's than yeses.
Okay. All right. So moving on with our session, as I explained at the beginning, that we'll be having a special topic. So we'll take a slight diversion from the questions and we'll jump on to today's topic. So today we'll be talking about compressor service kits and interchangeability. So Francis will be taking us through that. So Francis, it's your time.
Thank you, Mar. As Mar already pointed out, today we'll be talking about the interchangeability of compressor service kits. So we'll start with the compressor overhaul kits. And compressor overhaul kits include the flapper or reed valves. You have the cylinder sleeves, the caps or piston caps, and then you have the gaskets and the cylinder liners, also known as the O-rings. So over time, these components, all right, so as we can see on our graphics, we have the cylinder sleeves and then the piston caps, the cylinder liners or the O-rings. And to the next slide, we have the gaskets and as well as the reed or flapper valves. So over time, these components will wear out because of surface fatigue wear, among other factors, of course. So when these components wear out, the pressure produced by the compressor is reduced to a level below which is necessary for a concentrator to operate correctly. The most frequent component of the 5 mentioned above to wear out are the piston caps, as they are constantly wearing against the wall of the cylinder sleeves. So as we already said that the compressor wears out. So when a compressor is manufactured, it has the manufacturer produces the maximum flow and pressure readings for that specific compressor. So we have a wider variety of makes and models of compressors, each having different specifications. These specifications include the different sizes of the cylinder sleeves, piston caps, cylinder liners, gaskets, and among other factors as well. So To the next slide, okay, to this slide, we have the, sorry, the previous one, sorry. Yeah, we have the pressure, the maximum flow and pressure readings of a compressor. For the Thomas 2450, the maximum flow is 3 cubic flow meters or 84.9 liters per minute at a maximum pressure of 30 psi or 2.07 bars. And then you have the Thomas 2650 or the Thomas 2660 with a maximum flow of 4.6 cubic flow meters or 130 liters per minute and a maximum pressure of 45 psi or 3.1 bar. And you can check for the other models of the compressors to appreciate their maximum flow and their maximum pressures. So I said earlier, when the overhaul kits wear out, the compressor will be unable to reach these flows and pressures given by the manufacturer. Replacing the overhaul kits is the solution when the overhaul kits wear out. However, at times, one might only have unused or new overhaul kits of a certain model and have a worn-out compressor or worn-out compressor overhaul kits of a different model. In such cases, retrofitting with overhaul kits from the different model can work where only the dimensions match or where they're slightly different. For some compressor models, direct retrofitting is possible. That is in the case where the different dimensions of those overhaul kits that you want to replace match, so that you can like they match like exactly the same, so you can directly retrofit just taking the cylinder sleeve of that different model and replacing in the different model of compressor you want to fix. For some overhaul kits, it is possible, but only with the aid or either removal of spaces, and for other models it is impossible. So there are some factors that you need to consider when you're trying to retrofit, and these factors are different or they are specific for the different overhaul kits. Let's say, for example, for the cylinder sleeves, they have different factors. So moving on to the cylinder sleeves, we'll consider the factors that you should consider when you're trying to retrofit. So for the cylinder sleeves, you have the inner diameter. That's one factor that you should consider. And then you also have the outer diameter of the cylinder sleeve itself. And you have the height of the cylinder sleeve, how high it is. And you have the, for the cylinder sleeves, you should also consider the piston stroke height, or I can say how further above the piston goes up when it is running. So you can easily test that without running the compressor itself. You just have to rotate the blades by the sides of the compressor and see if the piston goes like further above the sleeve while you're retrofitting the sleeve itself. So there will be cases whereby two sleeves of two different models will slightly differ in height. The height difference can be compensated with the help of spaces. For example, we have the sleeves of the ZW 280 compressor, which measure 22.9 mm in height. This can be replaced with sleeves from a ZW75 compressor, and the sleeves from the ZW compressor measure 21.46 mm in height. So provide you will replace these, you replace the 280 compressor sleeves in the ZW75 compressor with the aid of spaces. So as you can see from the two heights, the ZW 280 sleeves have a height of 22.9 and the ZW75 compressor sleeves have a height of 21.6, a height difference of 1.44. So that means you might need to use spaces of different spaces. Spaces vary in sizes, that is in their thickness size. So that means you need to provide spaces of 1 mm, 1 millimeters, and 0.44 millimeters for you to be able to retrofit. So from the graphics, we can see where the spacer position is. It is just below the valve plate. I think the arrow is pointing at it. So yeah, you have that is where you place the the spacers. Just so you firstly place the spacer, and then you place the valve plate, and then the head gasket above everything else, and then you screw your compressor, and you can appreciate the spacers on the left side of the slide, on the right side of the slide, sorry. So for this compressor, they're using 3 spacers, and these spacers are of different, or let's say the 2 are of the same thickness, and one is of a different thickness. One is an a 1 mm thick spacer, and the other 2 are 0.3 millimeters thick spacers. So they were trying to compensate for a height of about 1.6 mm. So yeah, you can also do the same if you ever come across such a problem. So that is what you can consider on spacers. Moving on to the piston caps. For the piston caps, what you have to consider is the inner diameter. So a larger diameter piston cap can be used on a cap retainer of a slightly lesser diameter. For example, you can use the ZW90 caps, which have an inner diameter of 48 millimeters, on a ZW compressor piston compressor, which requires caps of 47.2 millimeters inner diameter. But then you can't use the caps of the ZW 140 on the ZW90 because the inner diameter is actually lower, is less than that of the ZW90. So the piston itself won't fit on the piston cap, sorry, won't fit on the cap retainer. So yeah, it won't be possible for you to do that. But then you can use a slightly larger diameter piston cap on a piston cap that on a piston that requires a lesser diameter. So in this case, you have to make sure that you tighten the cap retainer tightly to prevent any sideways movement of the cap when the compressor is operating. So just make sure you screw the screws in tightly enough. So moving on to the cylinder liners or the O-rings. For the O-rings, what you need to consider is the thickness of the O-ring itself and the diameter. Those are the 2 factors that you need to consider when you're trying to replace the liners. So just check the diameter itself, that they have to match exactly in the diameter, because the O-ring fits into a groove. So if the diameter doesn't match, you won't be able to fit it in. And also the thickness itself. If it's too thick, it won't be able to fit in the groove provided by the valve plate itself. So that's for the O-rings. And also for the gasket, the gasket as well, you have to consider the shape of the gasket, because the gaskets comes different gaskets for different models of compressors come in different shapes as well. So you should consider the shape of the gasket itself if it will be able to align into the grooves provided for that specific compressor. And also you need to consider the size as well on the gasket. So moving on to the last overhaul kit, which are the reed valves. So for the reed valves, you find out that mostly they're interchangeable on most compressors that we've come across with. They're interchangeable, so you can replace them. Maybe let's say from a ZW280 to a ZW75 compressor, you can interchange. You can take the ZW reed valves, ZW75 reed valves, and put them in the ZW280 reed valves, or vice versa. It'll work. So as you can see, we tried to compile the different piston cap dimensions as well as the cylinder sleeve dimensions. And for the piston caps, we only considered the inner diameter, but for the cylinder sleeves, we consider the inner diameter, outer diameter, as well as the height. So this information is available at your request for the different models of the compressors, but also it will make it available for you so that you can access it on oxygenalliance.org. Thank you, Maui.
Thank you very much, Francis, for that explanation. So if we have any questions or comments from the audience, please raise your hand, and then Francis will do his best to answer them. Also, if we have some additional comments, maybe from the other technicians, you are also welcome to add on to that. We have a hand from Amapri.
Yes, I had a question for Francis, and thank you very much for that explanation. Is it correct that with the spacers and the cylinder sleeves that you were talking about, that you can always do a cylinder sleeve that's bigger, but not one that's smaller, because you can use the spacers?
Okay, so for the spaces, for example, let's say you're trying to replace a lesser, okay, let's say for example you have a 20 mm. Let me just use this hypothetical example. You have a 20 mm height sleeve, and then you also have an 18 mm height of a certain sleeve. So you can you're trying to replace the 18 mm height sleeve with the 20 mm. So you can use the 20 mm, and then you have two spaces of 1 mm each, and then you can use that. That's what I meant. But then in case you want to do it vice versa, I think maybe let's say for example the compressor which was on the graphics. Let's say for example you have a sleeve which is lesser in height, let's say for example by 1.6. That means you have to remove the spaces in that case. I hope I've answered you.
Yes, I think that did answer. So essentially all compressors have the spacers already that they're using.
Not really. Some don't come with the spaces, but yes, essentially, yeah.
Got it. Thanks, Francis.
Great. All right. So moving on back to our questions now. So we'll now jump on to our next question, which says, I am a biomedical engineering student and I am working as an intern at a certain hospital. I was carrying out a preventative maintenance on a DeVille-based 515 concentrator, and when I checked the purity, I found that it was 80%. When I removed the cover of the concentrator, I checked for leakages with soapy water and discovered a leakage after the bacteria filter on the pipe which connects the flow meter outlet and the patient's outlet. I tried to remove the tubing so as to replace it, but in the process of removing the tubing, I accidentally broke the check valve, which was connected to the tubing. There was a spare check valve, and I replaced the broken one. When I finished servicing, I switched on the concentrator to check if the purity had improved, but unfortunately, there was no air coming out or at the patient's outlet. And after a few minutes, I heard a popping sound of the relief valve on the compressor. What could have caused this problem? So I will ask Sharon to please take this one up.
Thank you, Mari. Check valves are also known as one-way valves. So the check valve before the patient outlet in some concentrators allow oxygen to flow only in one direction, which is out of the concentrator. So this check valve prevents oxygen from flowing back into the concentrator, and also it prevents water in the humidifier bottle from being drawn into the unit. When this check valve is broken, one has to be cautious when replacing the valve. In your case, you might have placed the check valve wrongly. As a result, there was pressure buildup in the system, which in turn caused the popping up of the relief valve, as that was the only way through which air would be released if there was no loose connection in the tubings. So the long orientation of the check valve was blocking oxygen being released in the safe bed from reaching the patient outlet. So in order to solve this problem, ensure that the arrow on the check valve is pointing in the direction of airflow when you're replacing it with a spare one. There are other check valves which have no arrow on it to indicate the airflow direction. If your check valve has no arrow on it, then just try connecting the valve to a pipe which is where air is passing through, and see which orientation will allow air to pass through. And this will help you to orient the valve correctly in the graphics we can see that on the left, it shows different check valves that are used in oxygen concentrators. And on the right, we can see a check valve which is connected in 515 devil brace just before the patient outlet. Thank you.
Thank you very much, Sharon, for that explanation. So if we have any questions for Sharon, please raise your hand and then we'll help each other. And if we have some additional comments from the other technicians, you're also welcome to add on to the explanation she just gave. All right, it seems we do not have questions there. So moving on to our next question. So our next question says, I am a biomedical technician at a district hospital. We received a donation of 15 oxygen concentrators. We plan on keeping these concentrators in a storeroom until they are needed, since we already have concentrators available in all the wards. Are there recommendations on the appropriate storage conditions for concentrators? So I will ask Paulina to take this one up.
Thank you, Mwabi. Oxygen concentrators are mostly affected by dust, humidity, and temperature in storerooms. Accumulation of dust in the gross particle and inlet filters, muffler, and concentrator tubing can lead to blockages. Dust in the tubing also renders the air from the concentrator unsafe for the patient, even though it is rich in oxygen. This can cause bacterial infections, which can endanger the patient's life. Storing the oxygen concentrator in humid condition increases the amount of moisture present in the sieve beds, which greatly affects the functionality of the zeolite, which is the chemical element present in the sieve beds. Humidity reduces the absorbing ability of zeolite, which leads to low oxygen purities. Temperature also affects the functionality of zeolite and reduces the oxygen purity. So to ensure that you have an appropriate storage for oxygen concentrators, you would need to check the recommended working and storage conditions specified in the service manual for each and every machine that you want to store. For example, the recommended storage temperature for the ASAP Lifestyle concentrator is -20 to 60 degrees Celsius. It is also recommended that the concentrators remain in the boxes and in protective bags to slow down the buildup of dust and prevent exposure to moisture. Thank you, Mwabi.
Thank you very much, Paulina, for that explanation. So if you have any questions from the audience, you are free to ask and we will give you the answer. All right, so it seems we do not have any questions there. So we'll now get back to the question that we skipped, the question from Abena. Unfortunately, she still hasn't joined, so I think she will just have to have a look at the recording. So I will read out the question, just so those of you who were not there during the previous session, so that you can catch up. And then Francis will give the explanation on the extra details that we got. So the question says, I am a biomedical engineer at a hospital in Ashanti region of Ghana. I have 8 Cool-made oxygen concentrators, which indicates error 1 after 25 seconds or more after running. I searched for the manual online, and the error indicates that the pressure cannot reach standard pressure. What can I do to resolve this? So Francis, if you would please pick up on where we left from last week.
Thank you, Mar. So we'll start by going through what we talked about last time. So the probable causes for this might be that, one, you have worn-out service kits for the compressor, or you have leakages. So the solutions to the two problems are servicing the compressor by replacing the worn-out service kits if the kits are worn out, or if you have leakages, you should replace the broken tubes or pipes, or make sure you tie or screw any loose screws. So looking at the pictures, the problem of low pressure might be coming from the T connection, where part of the air gets diverted from the compressor to the air outlet. So we can see the T connector on the second picture, the picture on our right. It goes straight to the air outlet, and the air outlet is more visible on the first picture, the picture on the left, just next to the humidifier bottle. So I recommend that maybe they check for leakages. Also, they check for leakages starting from the compressor outlet to the air outlet. Also, check that the valve block is not leaking. If leakages do exist, correct them by replacing the broken pipes, or maybe, as I already said, screwing any loose screws, or might be that the push-in fittings, the fittings for the valve block are maybe loose and then they're leaking. So that's why I recommended that you check for leakages around the valve block as well. So looking at the design itself, we can notice that a couple of things are wrong, but maybe that's only if the intent is, as in you can't use the air outlet to supply directly to a patient. That's because you have a couple of things missing from the picture, from the design itself. So you don't have a product tank for the air outlet, and you don't have a pressure regulator, a bacterial filter, as well as a flow meter for the air outlet if the air is supposed to be supplied directly to a patient. But then if the design of the concentrator is that this machine, this oxygen concentrator, is to be used with another high flow device just to supply air from the compressor, then that's fine. But then what this means is that you can't use this air outlet to be supplied directly to a patient, because you'll be supplying the whole pressure from the compressor unregulated and unfiltered to the patient as well. So I recommend that a burner checks for the leakages, or if the air outlet is open along that line from the T connection. Thank you.
Thank you very much, Francis, for that explanation. I hope that helped to answer all the issues that she had. But Abena, if you get to review this video, you can always contact us through our email, so that if you still have any further issues, then we can help each other to sort them out. All right, so moving on with our questions now. So this also happens to be our final question of the day. So the question says, I am a technician at a health center. While conducting oxygen concentrator assessment in the wards, I came across a 515 DeVille-based concentrator that when I tested the purity with the oxygen analyzer, the purity was low. I noted the compressor kits were worn out, and after opening it at the maintenance workshop, after checking the Hobbs meter, it showed that the machine has run for longer hours than showed in the manual and needs to be serviced. But to my surprise, the concentrator's service LED was not illuminating, and the buzzer was not beeping, and nurses were still using it since there was no sign of malfunction of the machine. What could be the problem, and how can I solve this problem? So I'll ask George to take this one up.
Thank you, Maui. It's obvious that the all-nut compressor kits need to be replaced with a new one that will enable the compressor to work at the required level. And of course, the zeolite has to be changed for maximum quality output as well. With the LED not illuminating, firstly, check the connections on the control board, since there might be a loose connection with the RCD model. If there are any loose connections, please secure the connections and the LED will illuminate. As shown in the graphics, you can see on the left that OSD cable is loosely connected. And on the right, the cable is securely connected. So you need to check that. If the situation does not change, the problem might be with the PCB. So you might decide to change, and you're advised to replace the PCB. And for the buzzer, not producing a warning sound, this may happen if the buzzer is defective. The component is replaceable. So you may try to replace it with a new one. If that doesn't work, there might be a need to change the whole PCB. Thank you.
Thank you very much, George, for that explanation. If we have any questions or comments from the audience, you are welcome to raise your hand and ask, and George will do his best to answer the questions. If you also have some further comments from the other technicians, you are also free to add on to what George has just gave us. All right, so it seems we do not have any further questions or comments. So reaching this far, this now brings us to the end of our Concentrator Talk session today. And I would like to thank everyone for joining us. Remember that we are always here every Thursday from 2 to 3 p.m. Central African time. So please put it on your calendar so that you get reminders. We also encourage you to share with us your contact details if you haven't already done that in the chat, so that we can add you to our mailing list so that we keep sending you frequent updates from the Oxygen Alliance. We also have a website where all our work on the Oxygen Alliance is posted, so have a look at that. It's www.oxygenalliance.org. Amaprit, if you just paste that in the chat. We also have a YouTube channel where all the recordings of the previous Concentrator Talk sessions are posted. So have a look at it, and please remember to subscribe and hit the notifications bell when you get there, so that you get the reminders of when the videos are posted. So reaching this far, Amapri, I don't know if you have any additional comments to add on.
Just a thank you to everyone for joining. We definitely had some new people that came today, so very excited to see our Oxygen Alliance continue to grow. And just a reminder, please do get your intake forms in to become a full-fledged member of the Oxygen Alliance. And we look forward to welcoming you again.
Great. So until next time, have a great week, and we will see you again in our next session. Bye, everyone.
Bye.
Bye.
Thanks, everyone. Bye.
Thank you. Bye-bye.
Bye.
Thank you, everyone.